Okay, good afternoon, everyone. This talk is about enterprise-grade rolling upgrade. And we're going to give a short introduction for myself and my partner in crime who's just walking up the stage. We'll talk about what is rolling upgrade for those that you may not know what it is. Then we'll talk about some of the problems and enhancements we had to do. Because the understanding for a lot of people was if your wire compatibility and side-by-side installed, it should be sufficient. It turns out there are a number of issues to be addressed, and we go into details of the enhancements and the issues that we have addressed in the whole stack in order to do this. So how many of you here are, a show of hands on, you are admins or people who manage a Hadoop cluster, and that's why you want to understand how to do it in a rolling? Okay, so I would say about 60, 70. And the rest of you, because you want to see how to enhance your technology to, say, facilitate a rolling upgrade, or just for interest, I guess. Okay. Let me start. I'm actually at Hortonworks. I'm a founder of the company and a chief architect. I've been with the Hadoop team since 2007 at Yahoo. A bunch of us, who wrote the system, left the company in 2011. I've been actually working on Hadoop since then. I'm a PMC member and a committer. Prior to that, I worked on a number of technologies, including data center automation, and prior to that, I'm from Canada and have a PhD from there. My partner, who's just getting badged up, his name is Vinod, and he's a long-time committer since 2007. He's, of course, an Apache committer and a PMC member. And he's at Hortonworks, one of our key lead engineers, architects, and he's been working on MapReduce for a very long time. But he's actually worked on Yarn from day one, and is one of the main designers and implementers of Yarn. So he's going to take over from me in the middle of the talk. Okay, so Hadoop supports two upgrade modes right now. Traditionally, they support what we call stop the cluster upgrade. You shut down everything, and then you upgrade the binaries, and you start it. Traditionally, this was the only way to do. And enterprises today run critical applications on Hadoop, and many of these applications and services are online. And therefore, it does not make sense for them to shut down the cluster. They have a lot of SLAs and services that are running that they want to maintain, okay? And in order to do that, we've supported this thing called rolling upgrade. And here you upgrade the cluster and its services while the cluster is running, while the services continue to run and continue to make progress, okay? It's not like you pause it and finish upgrade, then you come back. And the upgrade time is not proportional to the amount of data, it's actually proportional to the number of nodes, because we upgrade one node at a time, okay? Now, one of the things that we've added is that while you're doing a rolling update, you may decide in the middle or at the end of it, you know what, things aren't going well, you expected some performance improvements in some areas, you're not getting it, you're seeing some funny behavior on some of the services, you want to go back. Or some of the applications start failing because they were using some APIs that got changed, and normally we don't break API compatibility, but maybe they were using some private APIs and you need to stop back and reinvestigate and come back. So you can go back. Here, all your new data that you were writing while you did the upgrade or any of the metadata will be preserved. And that's what we call a downgrade. Okay, there's something else we call a rollback, which is where we revert the cluster back to its previous state. All the metadata and the data goes back to the previous state, and here to a checkpointed state. And clearly here you lose the data that you created after the checkpoint time. And this one is something that you only do in an emergency kind of situation, okay? So both are supported. One of the things that the community kind of felt for a long time, and I've been working in Hadoop since 2007, it was like we only used to do wire compatibility of all of our protocols only on each release, and only on each of its dot releases. And we said, as soon as we get to wire compatibility, bang, we'll do rolling upgrade. And that's what the community felt a year or so ago. We'll be done. We only have to do this thing called side-by-side installs, and then we have wire compatibility. Unfortunately, that was not sufficient. Not if you wanted the data safety, not if you wanted to keep your jobs running and running correctly, not if you wanted to maintain the SLAs, and not if you wanted the option of doing downgrades and rollbacks. Okay, so data safety, HDFS used to have a way to do a checkpoint for an upgrade. It was actually one of the unique features, and I'll talk about that. And you have to fix that in order to do a rolling upgrade. Otherwise, you're actually taking a big risk. The other one was during service upgrade, you do not want degradation. And degradation can happen because every single daemon is restarted during an upgrade by definition, because you're going to stop the old version, start with the new version, which means write pipelines will break, which means all the application masters managing service will restart, all the node managers will restart, what will happen to their tasks, Hive service processing clients, so it cannot revert to a new version without losing those on the progress things. Clients must not see failures. Many of our components did not have retry, okay? And so the question people ask, wait a minute, Hadoop deals with failures and write pipelines and task failures and everything, what's the big deal? It turns out most of it would work except for, say, the Hive one and the client restart, because most components do support client retry. So what's the problem? It would mostly work. But the problem is that you're going to have a consistent degradation of every service, every daemon, and if you have a busy cluster, the worse it's going to be. So if you are willing to deal with a serious degradation of loss of SLA, then you could have done it. But we felt that wasn't good enough, so we had to put in a whole bunch of enhancements, okay, in order to fix that. Okay. The other one was maintaining the correct context of the application. In the past, the context of the job that the user submitted used to be based on the node on which it's running. Okay, now the node is going to have multiple versions of the binaries, and some nodes will have the new version, some nodes the old version of the binary. So what is the context of the application? You must have run the application in the context of what it was originally submitted, not where on the context of where it is running. Okay, because where it is running is changing. And so we needed to make sure that that context is correctly maintained. In fact, if you didn't worry about the problem, chances are it'll mostly work because your old and new binaries are mostly compatible. But every once in a while you run into problems. But this will still not be correct, and you won't be guaranteed correctness. Persistent state. In order to upgrade, downgrade, to make sure your state is backward compatible and forward compatible, your protocols are also your protocols are forward and backward compatible. So a lot of the persistent state in Hadoop was not compatible or not designed for, or might be backward compatible but not designed for forward compatibility. Similarly in wired compatibility, we had to look at that. And even the internal protocols, because the masters and the slaves are upgraded separately, so make sure you maintain the compatibility, okay? Because the upgrade is in a rolling fashion. Masters and slaves are upgraded differently. So the first thing we did, of course, was packaging side by side. And you must be able to install multiple versions. So some components are n, the others are n+1. Okay, and indeed, some of the daemons within the same component, like in HDFS, the name node may be n+1, and the data nodes are n. So we need to support that. Okay. In fact, even if they're running on the same node, you might have a data and name node running on the same node. Okay. So what we decided to do was, rather than go with a proprietary packaging solution, in fact, that could have locked a lot of our customers in, we decided to go with an industry standard. Okay, and we wanted, and there were several reasons for this. We wanted to support our rolling upgrade manually and via Ambari. Clearly, with Ambari, we could do a proprietary solution, but most other customers who are not using that would be in trouble. And that we felt there were advantages to the standard tools because it let you do install, uninstall, query using standard set of tools. You can deal with dependencies in a standard fashion. So the admin would not have to learn any new tools. Okay. And there was kind of benefits that, this would also, by the way, help us in doing a full stop the world rolling upgrade. Okay, so here's how the package layout works. So it turns out that the package name contains the version number. So Hadoop 2.2, the name I put over here on the screen, Hadoop _2_2_2 is RPM package name itself. The full thing is the package name. And the one below it, 2300, is actually a different package name. Okay, it's a related one, and then we do a layout. So when we lay out, for example, 2.2 on user HTTP with a directory name 2.2, okay, and then we lay out 2.3 in a different directory. So yeah, I'm giving an example of Hadoop and Hive components being installed in two versions being installed side by side. Then it turns out only one is active. So what we do is we have a label called current that then points to the current version of a particular component. But not just a particular component, but a particular daemon of a component. Because remember I told you, the name node and the data node could be running different versions. In fact, they are during the upgrade, and they may even be on the same node. So I cannot just deal with the current, so that's what we do there. And by the way, the clients may continue to run the old and the data node running the old till the full upgrade is finished. So that's how we deal with what is currently the version that is being run for a particular daemon or a client or this. Okay? And this particular change is managed by something called distro select, which lets you switch the version. Okay? And all the commands like user bin Hadoop point to where the client's current version is. Okay? So that's how the side-by-side installer. And the distro select tool that we supply does per component, per daemon selection. Okay? And it maintains stack consistency. So remember, a version of Hive that is running, let's say 2.2, it must continue the libraries of HDFS 2.2 or Yarn 2.2. The reason being is that's what QE tested. And we cannot test every single combinations. Okay, and so you want that consistency for the reason they were tested. Secondly, there may actually be dependencies. Okay, because Hive 2 used features of Hadoop 2, and Hive 3 uses features of Hadoop 3, and therefore you want that matching that happened. And so we maintain that matching by actually having a notion of a Hadoop home for the stack. Okay, and that's what we put in the wrapper scripts. So if you're familiar with a lot of the Hadoop RPMs that are installed, they have a notion, they have a wrapper stack in which we fix this Hadoop home that takes care of that. Okay. Similarly, configs. So configs normally stay back in the old place in / etc. or something. We do allow you to version to say all my configs are the same for the old and the new, but at times when you may want to say my new version requires a new variable, and when I update the binary, I want to put the new config variable in. So we allow you versioning of the config also if you like. And that is done via each of the binaries that you can see on the bottom of the last line of my slide. It says user HTTP 2.2 Hadoop conf. And so the 2.2 conf and the 2.3 conf can potentially point to different places. So every binary refers to the config from its binary home location. And that now gives us the freedom to actually upgrade the configs in a rolling fashion, synchronized with the binary if we like. Ambari does that. Manually, you could do that, or you could decide to do it non-synchronized, but we give you that option and the flexibility. Okay, so I'm going to talk a little bit about HDFS enhancement. I'm going to give it to Vinod to talk about Yarn and some of the Hive enhancements, then kind of come back and conclude on what we're doing. Okay, so HDFS data safety. It's one of the really unique features that Hadoop had when I started to work on 2007 was that most of the time you go and install, let's say, ext4 or something. It tells you back up all your data before you start the upgrade. If anything's lost, it's your problem, right? And so most people will put in a USB, back it up. That cannot be done in Hadoop, right? You don't have that many USBs. You don't have, unless you have another cluster. So that's a pain. So right from the early days, okay, we had a notion of saving the states. Of course, we used to save the metadata of the name node, but in the data nodes, we also used to keep hard links to the blocks of the files. So if there was an accidental glitch in the new software, say the new name node wakes up, has a glitch in the software, looks at its image and says, there are no files. Then it can just go in parallel and tell all the data nodes come and say, here are blocks, here are blocks, here are blocks, and it'll say, delete them. I don't know anything about them. It shows me there are no files, there's only /. Bang, it'll delete in parallel. Okay? And that's a software glitch. And that's where you would say, I go back to my backup. And so what we do is we basically go and do the hard links of all the blocks so that if it does delete them, we do have the blocks. So it's a very, very rare thing to happen, but it is actually a useful feature. And so that is something that was there that, by the way, did not work with rolling upgrade. So we had to fix that, okay, in order to make that work. And every upgrade should be done in the past with upgrade checkpoint, and now in the future with this rolling upgrade enhancements that we have done. Okay, so we did that, and so what we do is we do a marker for where the checkpoint started, and so we can roll back to that position, and we also do this hard link notion that we had in the old system, except we kind of do it slightly differently. We don't do deletes. When the delete happens, we just move the block. Okay, so the data node code is changed to treat all deletes as a move. Okay, and we've also added support for downgrade capability by making sure that our FS image is actually written in something, a thing called protobuf. So it makes us easier to do forward compatibility, not just backward compatibility. Okay, The other one is a fast data node restart. So we enhance the restart of the data node so that you can upgrade a few thousand node clusters very quickly. And the other one is the pipeline. So every node is, remember, going to start, and the pipeline is going to break, and it's going to do some recovery operation. So what we did was we did an enhancement so that the pipeline is recovered back to the same node, because we know the same node is going to start back. Okay, and so that was an enhancement that has been put in, and it also retains the number of replicas during a rolling upgrade. Okay, and of course there's one feature we always had for quite a while, which was HA, and we take advantage of that during rolling upgrade. So this is not a new feature, but it's an important part of the upgrade. So now I'll hand it over to Vinod, who's going to talk about Yarn.
All right, thanks. Check. So when we talked about Yarn rolling upgrades, we always used to joke internally saying, it's okay, it's not a big deal. When you upgrade HDFS or HBase and something goes wrong, you may lose data, right? For Yarn, we always used to say, nah, I'm lazy, I don't want to do it. The worst you can do is, you lose some applications, right? But it turns out people have written lots of applications and frameworks on top of applications and pipelines, which are very complex, which needs a lot of careful orchestration. The stop-the-world upgrade that we always used to prescribe in Yarn, turns out recovering from such an upgrade would essentially mean you kill all the applications and restart all the pipelines carefully. And if you're not careful enough, then you may end up corrupting data, etc. So turns out it's the same set of problems. And kind of he had to convince us back that we have to get our act together and fix Yarn rolling upgrades. And the kind of enhancements that we needed were, the requirement is basically to say, while Yarn is going through upgrades, or maybe even the entire compute platform is going through the upgrade, nothing should really get impacted, right? So the first step as part of that was in 2013, we added support for the resource manager to retain application queue. Which means before 2013, if you restarted the resource manager, it would forget about everything that was happening in the cluster. You have to restart applications, restart pipeline very carefully, like I was mentioning before. So after that feature, what you could do is you don't need to resubmit the running applications, but anything else that was in the process of submission, you'll have to retry that anyways. What you would get out of that feature is any running application will simply get re-kicked from where it was. You would still lose all the running work. Any running containers will get killed and restarted, etc. But the notion of application queues themselves, it gets persisted, so the users don't need to carefully resubmit them back. In 2014, we have implemented Yarn Resource Manager failover so that even if the Resource Manager machine goes down, in an active standby architecture, the standby can take over the responsibilities and kind of minimize disruption. This restart and recovery, our goal was to actually support an order of tens of seconds of recovery, so that in the worst case, clients are forced to retry while the resource manager fails over to the new machine and rereads all the state. The next step was to actually support restarting the resource manager in the cluster while retaining all the applications, while retaining all the running containers. And turns out this is, if designed to the extreme, it could have been a very expensive operation, because in a large enough cluster, the resource manager will be dishing out a lot of containers, which may be finishing very fast. So you have a lot of throughput of containers, recording each and every one of those events, starting containers, finishing containers, starting apps and finishing apps. There's nothing you can do in a large enough cluster to withstand that kind of high throughput, right? So what we ended up deciding is we only retain metadata of the applications, and for the container level state, we instead turn around and talk to individual app masters and the node managers to figure out what exactly is happening in the cluster. That way, the resource manager doesn't need to store a lot of information. It stores sufficient enough information, and the remaining information that it needs in terms of figuring out what container is running, where it is running, what app master is running, etc. It gets that information from the node manager. And node manager is a trusted component because resource manager and node managers form the core of the platform. On individual node managers, during an upgrade, node manager goes down and comes back up. And in the previous world, we used to kill all the containers, or we used to forget about them, right? And to support a work preserving restart the way I mentioned before, you also need to say, upgrade the node manager to the next version, but reattach to the old work that was running, right? To do that, we, Yahoo folks primarily driven this feature. There's a local database on every single machine where node manager kind of records which container came in, which finished. Compared to the resource manager, it's much less in number, a couple of order of magnitude less. The node managers record what containers came in, what they were doing, what files were downloaded, et cetera, et cetera. And it also records, at least for the Unix process, it records the PIDs. So that when the next version of the node manager comes back up, it reads through the PIDs and reattaches to the old containers, and the world is as usual. In addition to the resource manager and node managers restarts, we had to do a bunch of compatibility features in line with the rest of the things that Sanjay talked about, which includes versioning of the state stores so that the new resource manager can come up, read the old data, perform any compatibility upgrades that it has to do during an upgrade or a downgrade. Similarly, the node manager being able to read the local database state or written by the old node manager and migrate it to the new version, et cetera. Security tokens also get propagated throughout the system, and as apps and platform keep, they get upgraded, you need to be able to understand old tokens, new tokens, et cetera. I think we lost a picture there. Okay. So this was something that Sanjay briefly talked about. In addition to the platform going to the new version and servers and the per node agents being able to talk to each other, you also want to be able to say, I submitted a MapReduce application on version 2.2. Just because the platform went to 2.3 or 2.4 should not be affecting my application, right? Because I've already submitted it in the past, and it should just run the way I expected it to run in the previous world, right? The whole notion of upgrades happening in a cluster should be completely transparent. So to do that, we had to change MapReduce. We had to change the way MapReduce gets implemented, the way it executes on a cluster. In the previous world, MapReduce would depend on installation of MapReduce libraries on every machine. We have gone away from that model to say all of MapReduce will be part of distributed cache. So at submission time, we clearly bind MapReduce to a specific version of the framework. And once it's running, it's not affected by the platform upgrade, right? And we had to, and this is a general practice for all Yarn applications, including Taze, Spark, Slider, and so on. The other thing is, we talked about libraries, right? There is also configuration. In the previous world, at least some of the frameworks like MapReduce, they always depended on the client-side configuration. But if you're not careful enough, you would have depended on the cluster-side, server-side configuration. Again, while the cluster upgrades, you may or may not get the same configuration files. Maybe they get relocated to a different location, et cetera, depending on the orchestration. So we also had to make sure that configuration of every application, every query, every workflow is always driven from the submission machine, so that it gets frozen in time and it doesn't get impacted by any upgrade that happens in the cluster. So a brief look at how this whole thing looks in the context of Yarn. So here's a cluster where the resource manager is, it has failover enabled. So there's an active resource manager, standby resource manager. And there are two versions. The older version is orangish, and new version is green. At a specific point of time, the resource managers have already moved to the new version. One node manager has to move to the new version, and the rest of the node managers are on the old version. They can all talk to the resource managers because the compatibility that we guarantee is new and old per node agents can talk to the new resource managers. And as you can see, the application itself, which is running across the cluster in a distributed fashion, it's still on the old version. So it's not affected even though the cluster is going through an upgrade. In terms of Hive, again, similar to every other daemon that we have talked about, we needed the Hive servers like Hive Metastore and Hive Server to be able to restart fast, do not lose work, et cetera. With Hive Server 2, we had to do a little more because you may have submitted a query to Hive Server which may be in progress. And if you want to restart Hive Server to basically upgrade to the next version, you would have to kill the active query in progress, right? To avoid this, we have implemented a feature wherein you inform the old Hive Server to say, drain all the active queries that are in progress, and then die sanely without accepting any more new connections. And through Zookeeper, the clients will somehow figure out where to go to submit new queries to. And that's how we have basically made sure that any work in progress is not lost in the context of Hive queries. At the same time, you go to the new versions, and it's all transparently taken care of by the framework components. And one of the side benefits of doing this is we've achieved load balancing of the Hive server too. Also, you can imagine using the same functionality to load balancing queries depending on how many are incoming. I think that's the last one I wanted to cover. Okay,
okay, thanks. So we'll kind of briefly tell you how the upgrade happens through Ambari and how you could actually do it also via your mails. Because typically this is the upgrade orchestration runbook that Ambari follows, and that at a high level. So we basically do certain levels of prerequisite. You must be running HA for name node, while for some of the other components, HA is open. You check, make sure that the configs are correct for the new version. Certain configurations, for example, retry must be set, things like that. Then what you do is you install bits, you do a database backup, and you do HDFS checkpoint, HBase checkpoint. And the upgrade hasn't started so far. Okay, and then you do an upgrade in rolling fashion, and then you say everything is good, you finalize, you decide in the middle things are not good, or whatever reason, you downgrade in a rolling fashion, or if things are really bad or something you want to go back, you can go back to your checkpointed state. Okay, so that's the kind of overall structure. So Ambari supports a fully rolling upgrade. It verifies all the prerequisites for you. It performs the HDFS upgrade checkpoint and also the HBase checkpoint. But it prompts you to do your database checkpoint because you have a choice of which database you've used. And then it performs the rolling upgrade in the right order. And at appropriate times, it runs sanity checks, what we call smoke tests, to make sure that the upgrade has actually succeeded. Okay. And then it even asks you at certain points to the admin saying, okay, I've done 20% of the cluster, go verify that your applications are running. Look, you can check the status of the system, etc. And then you say proceed or don't proceed. And then it finishes off. And of course, it does the downgrade also. Okay, we have published a runbook for this. So if you don't use Ambari, you can follow the runbook. You can do it manually by following the runbook, or you could try and write the automated scripts for that. Writing those scripts is non-trivial because you have to deal with all the failures, conditions, partial failures, and things like that. You kind of be redoing what Ambari's done. Clearly, it's doable, but it's important to actually follow the runbook quite carefully, okay, and do that. So typically, what happens is the upgrade, Ambari, of course, does the process and does the service switch, etc. Okay, it typically starts. It actually starts with Zookeeper and Ranger, because these are two of the critical components that oversee everything else. Okay, you can be used by everything else. Ranger does the authorization for many components centrally. And after that, you do the masters, and then you do the slaves. In masters of the core systems, you do HDFS, YARN, HBase. You do first the masters, and then the slaves, and you do master of failover from active to standby, and then you upgrade them. Both masters upgrade, then you do the slaves. Okay. And then after you've done, and also typically you do what we do in the slaves, and which is what you would do in your manual, is you would wait after 10-20% of your slaves are done, verify, and then continue. But it does that. Then you do Hive, Uzi, Falcon. Then you do all the clients, okay, of components that we consider to be inside the cluster code. And then you do things that are generally often installed with Hadoop but are not considered part of the cluster. Things like Kafka, Knox, which is an edge thing. Storm, we do separately, and then Slider, Flume, and Hue. Okay, and then you either finalize or don't finalize. If you finalize, you're done. Okay, a 2,000 node cluster, for example, at one of our customers like Yahoo, they take about 2 days to complete that. Yeah, and they don't use Ambari; they have their own scripts to do that. Okay, but remember, the entire cluster is active and running. Clearly, at any point, you could do a downgrade. Okay, and then finalize. When you finalize, basically what you've done is you've thrown away your checkpoint. Okay, the checkpoint for HBase is not a big deal. You can keep it for longer, but the checkpoint for HDFS is critical because HDFS is not deleting new files, and so you're accumulating, and your capacity of the free space is going down. So you cannot not finalize for very long. Okay. So to summarize that, we have a lot of customers that are doing critical services. For them, a live upgrade is something that is critical and needed. Okay, and we let you do that without degradation of your services and maintaining your SLAs. Okay, we had to enhance a number of components. We are using standard packaging solution. We're not using anything proprietary that locks you into Hortonworks. Okay, there is data safety because of HDFS checkpoints and write pipelines being correctly repaired. We maintain SLAs because we make sure that the tasks that are running are restarted, are reused and not restarted, are reused. Application masters are reused. Okay, a lot of state recovery happens. Hive has got the work that goes in progress, which keeps all your work going forward. You're not having a lot of disruption. We use the right context to have the correctness happen in the cluster. And we, of course, allow you for downgrades and rollback in case you wish to do that or is necessary. And you might ask, all these enhancements you've made, are they truly open source? Have they been pushed back to Apache? And answer is, of course, yes. That's how Hortonworks does its business. Every single line of code has been pushed back that we have done in any of these enhancements. Okay, Apache doesn't have a packaging solution, so that is something we have described how we do, but there's no place to push it back. Okay, so that's it. If you have questions, there are 2 microphones and in the front, so please come up to the microphones if you have any questions that you wish to ask.
You mentioned for the yarn, the node work preserving node manager restarts. The PIDs are saved for Linux or Unix systems only. What about Windows?
Yeah, so Windows rolling upgrade is not something that exists today. But you can also imagine other containers. So what I described is Linux type, Unix type process tree implementations, right? But once you move to things like Docker and stuff, you also have to make sure that they get reattached and so on. Right. So there is work in progress to refactor some of this to basically say, make it an artifact of a container type instead of PIDs, etc. Okay. Yeah, so that's a work in progress. Anyway.
So today we cannot use work preserving node manager restarts on Windows, basically.
Yeah, so you will have to reattach job objects and stuff. That's not done. That's right.
Thanks.
Yeah.
Other questions?
Can I just upgrade one of components, like I upgrade the Hive instead of upgrade the HDFS?
So you could, if you're doing manual rolling upgrade, absolutely you can do that. If you are using Ambari, we don't offer that option today, and we may in the future to say I only want to upgrade Hive or HDFS. So for example, what we might offer in the future is an ability to say first upgrade HDFS and do everything in layers. Now,
so for
the mechanisms we have done will let you say upgrade just Hive. The question.
So the sequence in your chart is the steps I follow to manual upgrade, right? So yes. for the Ambari, how Ambari do auto upgrade? So they figure out a tag based on the dependency or something.
So Ambari will upgrade the whole cluster in only one fashion. Okay.
So just the one shot to upgrade everything?
Depending on what you have installed, it clearly knows the order. But I guess that's what you're asking.
So if you've installed, let's say, HDFS, Yarn and Hive, for example, okay? And Spark, for example, it'll upgrade all those 3 components, okay? Now, what you're asking is, I just want to upgrade Hive.
Right,
Ambari doesn't offer an automated way of this.
Yeah.
The technology we have created here, all the enhancements, our packaging solution will let you do that. And so if you're a manual upgrade, you could do that. Ambari might offer that in the future. There's one caveat you need to think about. We today test the whole stack. Yeah. So we test stack 2 version, we test stack 3 version, stack 4 version, stack 5 version. We don't always test the mixed combination. We maintain compatibility and the chances are they're going to work, but we have not tested it. And so that's something that we will consider. There it is more an issue of what is the QA process. Okay, so for example, if it was a dot release, you would probably be safe upgrading just Hive. If you're doing a more important release, like say 2.3 to 2.4 to 2.5 instead of 2.3.1, then you need to think about that. Do I just want to upgrade Hive? Chances are it'll work, okay, but it may not. So it's a testing issue.
There is also a community aspect to it. Each of these individual projects are fundamentally driven by different communities. So we have to do a good job of defining compatibilities across versions, across projects, right? So if you pick up a Hive version which clearly says that it won't work with an installed version of HDFS or Yarn, for example, then clearly it will not work. So there's also the community aspect to it in addition to testing cross-version components.
Like I think, for example, the dependence between Hive and Tez, that you better upgrade them together. Okay, and maybe I would say the next one is maybe closer between Hive and Yarn. Hive and HDFS are probably more likely to stay compatible because they don't have such a high dependency, okay? But that's an excellent question.
Yeah.
So we'll be moving that.
So you guys had a slide where you showed moving shared libraries to HDFS, and you kind of went past it quickly. Mm-hmm. Is there a way you could pop back and maybe elaborate on that one?
Sure.
Which one was it?
It should be on the...
Not this one, before
the one before the context, yeah. Yeah, that one.
Yeah, so the bottom.
Oh, so I did talk about it. Fundamentally, you need to put all the frameworks, installed in HDFS. Because like I was saying, if you start depending on per node installs of, let's say, MapReduce, underneath the application suite, the installer may upgrade it to the next version. So on one machine, you may get version 2.3, but by the time you went to the next machine, you may have gotten the new version. And today, we cannot guarantee this cross-version compatibility of different. You can imagine map tasks running on 2.2, reduce tasks running on 2.3 in the same application, right? That's something that we cannot support. So what we end up saying is, put your libraries, all of your libraries on HDFS. At runtime, Yarn has this notion of localization. So you download the 2.2 libraries, and you stick to them. And that's completely decoupled because it's no longer a per node install. It's part of what we call the Yarn distributed cache. So that's how you basically say every task in this job, be it MapReduce, Tez, Spark, they're all tied to the version that was at the time of submission.
So one actually advantage of this thing is that this finally gives you the promise that Yarn had that you can run multiple versions of the same library at the same time. So you could have one customer run MapReduce 1, some client run MapReduce 2. They both can now run in parallel. Okay. Yeah. In fact, you can run your Hive jobs like that with one issue. That Hive also is this thing called Hive Server. So if you're using Hive CLI and it's all being submitted as a Hive job, Yarn job, okay, then it'll actually work modulo the meta server because you're not using Hive Server, but you're using the meta store. And meta store usually be compatible. So you could actually just, if you're submitting a SQL query without going via the Hive server, you can actually run 2 different versions at the same time, try it out, and then upgrade your customers as you like, okay? Yeah. So this actually delivers on one of a long promise of Yarn.
Decoupling the platform upgrades from the framework upgrades, yeah.
Does it also apply to the client libraries for HDFS and for Yarn, or just?
That's a good question. So I kind of glossed over that here.
This question was about client libraries?
So the question was about the Yarn and HDFS libraries that are needed by the applications. So what we really suggest is you have MapReduce, let's assume 2.3 and 2.4, or you've changed a small thing in speculative execution. So the way you would make this work is you package not just the MapReduce framework libraries, but also its dependencies on the platform client jars. So you would package HDFS 2.3, Yarn 2.3, Zookeeper 2.3, etc. It's completely self-contained. Think of like Docker, right? So once you've launched a Docker container, nothing changes in that container. That's exactly what this is, except it's a poor man's container based on tarball, etc. Does it answer your question? Yeah. Go ahead, please.
Are there any HBase ramifications or implications of the HDFS rolling upgrade?
I can repeat the question. Are there any ramifications on HBase upgrades, downgrades?
Yeah, any HBase impact?
Nothing that came up. We did HBase used to support a checkpoint. We used that. Nothing that I remember we ran into. So HBase, we didn't have any real enhancement that we had to do. No, HBase was fairly clean.
Does pushing all the application framework into the distributed cache affect the startup time drastically for every job, if every job has to pull it down on startup?
For the first application, yes.
Okay.
For the first application on every machine. It will be a little slow. We have we have done some benchmarks. Right now, even the MapReduce tarball, for example, it's pretty fat. We want to thin it down all the way. Today, it packages everything in the world. For example, HDFS till now did not have a notion of a client jar separately from a server jar. You would package name node, data node, everything as part of that, right? So there are a couple of Jiras which talk about thinning this whole tarball down to its the smallest size possible, which includes harder things like separation of client and server in HDFS, etc. But yeah, so it will take a while for the first application, but once it's installed, remember it's only once per version, right? So MapReduce 2.2.x, it will be downloaded once for the first time. After that, every other application will simply use it on the local distributed cache.
You said after you do the finalize on the rolling upgrade, it removes the checkpoint. Let's say I've done a rolling upgrade, I've finalized the upgrade, but my BI tool has some problems and I don't recognize that there's performance problems from the upgrade 2 or 3 days afterwards. How easy is it to go back and do a downgrade? And then second part of the question, are the old binaries for different services like Hive still remaining on the system there?
They remain they can remain as long as you like.
Okay.
If you haven't done the finalize, you can go back, okay, downgrade or roll back. It turns out that if you haven't done even if you have done the finalize, you can always downgrade. We don't support it in Embody today, okay, but you can downgrade if you're doing it manually. Of course, you realize that once you finalize, you can't do a rollback to an older state, but downgrade is actually possible. Okay, because downgrade doesn't go to any previous state, it uses the current one. So downgrade you could do, don't support it in Ambari to do a downgrade after a finalize, but yes, you can do it. And all the binaries are kept. Ambari, I believe, keeps it till later on, then may ask you to remove it much later on. You can give 2, 3, 5 versions of the binary if you like.
Okay, thank you.
Okay, any more questions?
There's one we have. So he kind of, so the question was, there is an option in Ambari to finalize later, right? That's the same thing that Sanjay was talking about. You can do a rolling upgrade and wait for a while till you actually make a decision to finalize the cluster upgrade.
Yes.
Right.
Mr. Ambari is here.
It just misses the window. You could do it later.
So
thanks.
Yeah, actually, a lot of people helped in this rolling upgrade. It was a cross-component effort. Owen O'Malley helped on a lot of the design of number of issues and with the layout stuff. Raja did all the layout work. The Ambari team played a big role in actually orchestrating. Alejandro is actually one of the guys who worked on the rolling upgrade, and in fact on the checkpointing on HDFS, although Constantine did not work on the rolling upgrade part of it. He's actually in the audience. He was actually the guy who originally put in the notion of doing an upgrade checkpoint in the original, in HDFS, which is the full upgrade one. He's sitting in the audience, so that was actually a feature that we enhanced. Any questions? Yes, one more question.
Can you upgrade JDKs as part of the rolling upgrade? No.
So
many of these things, like even enabling HA, I'm not sure he talked about it. You should not be fundamentally changing the way the cluster was, right? You cannot add new components. You cannot add, change a non-HA cluster to be HA cluster, etc. You have to do them either before the upgrade or after the upgrade. So it's hard enough for us to just do that. So you can't do that. You'll have to upgrade JDKs after the fact. I think there's one last question for me.
If I want to roll back to the previous version, then what kind of description would it really create?
Okay, so main difference between rollback and downgrade. Downgrade is, let's say after I start the upgrade, I do a checkpoint, I create a file called foo, and I delete another file, old one called bar. Okay, so foo has been created, bar has been deleted. If I do a downgrade, both those files will remain. My new old software will see those two, will see the foo file and will not see the data because you created one, deleted. If you do rollback, then you checkpoint, and therefore you will not see foo, because foo wasn't there before the checkpoint, but you will see bar because bar was deleted, but it was not deleted before the checkpoint. So the disruption you are seeing is that you are any application that were actively creating, deleting data, that information is gone. So typically we will do a downgrade, not a rollback. Rollback is when something really bad happens. It's like you did a database backup and then something, and you're working on something really bad, it got corrupted, then you go back. Okay? Okay, that looks like that's it. Thank you very much.
Thank you.